All right, so here we are, we're going to divide radicals, and when we divide radicals, here's one of the things that we're always going to have to remember. If I'm trying to do radical 15 divided by radical 12, it's not that I'm going to sit there and divide them by each other. So here is a really good fact to know straight off the bat. You can never, ever, ever have a radical in a denominator. Denominator is the bottom part. So this is perfectly fine, radical 15, it's just radical 12 is not allowed. It can't appear in the bottom. So here's what we have to do. Ironically, with dividing, we actually really don't do much dividing at all. Okay, so since we're not allowed to have this radical 12 in the bottom, we're going to do this thing called rationalizing. And that is where we basically get the radical out of the bottom. So here's how we rationalize. We multiply the bottom by radical 12 and also the top. So say it with me, kids. Whatever you do to the bottom, you also simultaneously do to the top. All right, now, the reason why we're multiplying by radical 12 is whenever I multiply a radical number, whatever it be, and this one happens to be 12, by itself, look what's going to happen. The radical will eventually dissolve, and we'll talk about that and why. What is radical 12 times radical 12? Radical 144. Now, if you're saying, why is there still a radical there? She said it's going to go away. It will, trust me. Why? Well, I'm just going to continue on with the bottom. I'll do the numerator in a second. Hey, what is the square root of 144? Does it happen to have a perfect square? I think it does. 12. So one of the things that we'll probably start to notice happening quite a bit on these questions is whenever we have to rationalize and get rid of a radical in the bottom, we're going to multiply it by itself. And again, eventually the radical will dissolve itself out. So I'll just have 12 in the denominator. However, that's obviously not going to happen to the numerator. What's 15? Radical 15 times radical 12? Radical 180. Now, I'm not going to bring that over to my numerator, and we should all know why. If you've watched any of my videos over the last couple of weeks, 180 is a fairly large number, and I'm just thinking that you could probably break it down. So here's what I'm going to do. I'm going to do it a little differently. I'm going to write all the factors of 180 up here. 1 and 180, 2 and 90, 3 and 60. And again, these are just two numbers that multiply into 180. So if you wanted to see the next factor, let's think and wonder if it is divisible by 4. It is. 4 and 45. And notice how, again, as I'm going through the numbers, like 1, 2, 3, and 4, these numbers are getting smaller and smaller. So I'm kind of doing like a little factor rainbow. Is 180 divisible by 5? Yes. 5 and 36. Is it divisible by 6? I think it is. 6 and 30. Is it divisible by 7? Here's where we may get one where it's not. That's okay. It doesn't have to be. It's not. Is 180 divisible by 8? Nope. Is 180 divisible by 9? 9 and 20. And again, one more time. I say the word again a lot. I realize that when I'm filming myself. Is as these numbers are going up, these numbers are decreasing. So I'm just going to keep on going. I need to kind of like make the gap be smaller than between 9 and 20. Is 180 divisible by 10? 10 and 18. Getting a little closer. Is 180 divisible by 11? Nope. 180 divisible by 12? Sorry. Is it divisible by 12? Yes, 12 and 15. And that is the last set of factors. And it is because it's not divisible by 13, it's not divisible by 14. If you think it is, try seeing it on your calculator at home. I know you guys aren't going outside, so don't go outside. Stay well. All right, I'm going to look for numbers that have perfect squares. 1, 4, 36. That's a good one. None of the other numbers have perfect squares, so here's how I'm going to rewrite the square root of 180. 5 times 36. I am using this pair because that is the largest perfect square out of the 3 that I circled here. Now, of course, I'm not going to leave it like that, and the whole point is I'm going to take out 36. Just like I pointed out before, it does, in fact, have a perfect square. It's 6. So 6, radical 5. Radical 5 will always stay out on the inside. It's never going to come out of the radical ever, and that's going to currently be over 12. Now here's the one thing that we have to do. After all that work of rationalizing and factoring out, here is my answer, but not my final answer. I could simplify this. I mean, I could lower it down. It's your fan favorite. It's a fraction. So I'm just going to see 6 and 12. That's like 6/12 right there. I'm not going to touch the radical 5. I mean, that's set in stone at this point. I'm not going to change that. But 6/12, they are both divisible by something. What's 6 divisible by? Itself. It cancels out. And then 12 is also divisible by 6. So that becomes 2. So that's as low as we could possibly go now. So radical 5 over 2 is our final answer. Let's do one more. I know this video is kind of getting long. So here's what we're going to have to do again. We're going to be dividing these, which ironically, we really don't do much dividing at all. It's just that I can't have this little portion in the bottom. Why? Again, you can never, ever, ever have a radical in the denominator. So again, I'm going to rationalize it. This is called rationalizing. How do I rationalize radical 3 out of there? I multiply by radical 3. This one has a 4 up front, but that's okay. 4 can be there as much as it wants to be. It's that this little portion right here is the issue. So we're going to rationalize both the bottom and where else? The top. All right. So I'll stay in order right now. I won't do just the bottom first. Again, I'm not going to multiply this 3 by anything because these are both radicals. So 3 will still be 3. And then what is radical 27 times radical 3? What does that end up being? Radical 81. What an interesting number. All right. 4 is not going to be multiplied by anything. I'll keep that out here. And then radical 3 times radical 3. Radical 9. Now, on this one, I want to draw attention to we are going to simplify this answer and we're going to bring it down as low as possible, but I don't really need to factor out the radical. Because I want you to really pay attention to the two numbers. 81 has a square root over it and 9. Does 81 have a perfect square? It's in that list. And again, if you notice that list at the beginning of this whole learning process, you might want to print it out. It's still on the main page. What's the square root of 81, guys? 9. Has a perfect square already. Same as 9. Does anyone know the perfect square of 9? It's 3. All right. So again, look, I don't have any radicals, period. I had this whole radical problem. Now they all kind of dissolved and canceled out, etc. So now I'm just going to bring everything down as low as possible. However, I don't really need to multiply here because there's a 3 in the bottom, 3 in the top. And what do they do to each other? Cancel each other out. So now I am only left with 9 over 4, which is my simplified lowest possible answer.